Well, it would be reasonable to consider that all the students studying class 12 science are well acquainted with the primary knowledge of current electricity that has been already discussed in class 10. If someone of you want to study that or recapitulate the matter already studied in class 10, you may go through the videos uploaded for class 10, and it will be reasonable to assume that all the students studying in class 12 physics or science are able to understand the matter discussed in English language, because you will have to face same classes just after 1 year. You will go to study in different prestigious institutions like engineering colleges and medical colleges and other degree colleges, and all the subject matter of science will be discussed in English. So better to be acquainted with the knowledge or acquainted with the language or mode of presentation in English language. In case of any problem, you may communicate with me, and then I shall try to reorient my classes. And this class is about origin of resistivity, and perhaps you know the expression for Ohm's law. V is equal to IR. V is equal to IR. No further discussion is required for this part. This is Ohm's law, and R is resistance. R is equal to rho L by A, expression for resistance, and particularly rho. This one is known as resistivity. Rho is specific resistance or resistivity, and we shall discuss in this class about the origin of resistivity. You may consult a book published by NCERT for physics, NCERT for class 12, page number 97. And the matter of discussion in this class has been displayed and written in that particular page. You may consult this page 97 and 98 also, these two pages. Now, this boundary represents the interior of any conductor, and these are atoms. Atoms, rather it should be called ions. Ions. And this green one is electron. And these are free electrons. That means free electrons are free to move throughout the interior of the conductor. That means this electron may reside at any point of the conductor. Suppose this is the point, and this point, there is one electron here. And there are so many electrons. There are so many electrons inside the interior of the conductor, and the behavior of the electrons are like gas molecules. You know about the kinetic theory of gases. Actually, gas molecules in temperature, when temperature is greater than 0 Kelvin, all the gas molecules are moving. The gas molecule, suppose this is a gas molecule, and this gas molecule is free to move inside the container along all possible directions. That means this gas molecule may move along this direction with this speed, or along this direction with this speed, all possible velocities, all possible speeds, and all possible directions. These gas molecules can move. And the molecules, this molecule, when moves, one molecule moves and encounters with another molecule, similar molecule, a collision occurs. And this collision is perfectly elastic, you know. Similarly, inside the conductor, these electrons can move in all possible directions and with all possible speeds. Okay. So, suppose there are, in this specimen, there are 1, 2, 3, 4, 5, 6, 7 electrons. There are 7 electrons, though this is for consideration only. Actually, the number of electrons per unit volume is equal to is 10 to the power 20 to 23 or 29 of this order. Number of electrons per unit meter, per unit volume. Actually, this is the actual number. So this high number is not possible to represent here. So that for simplicity, we have taken only 7 electrons. And as the electrons move in all possible directions, there are so many different directions. This is one direction, this is another direction, this is another direction. There is no fixed direction. This is another direction, this is another direction. And if we add all the velocities vectorially, then we will get the summation of Vi from I is equal to 1 to n. Summation of Vi is equal to 0, because the algebraic sum of all these vectors will be 0. Rather, it should be written as like this. If we multiply by 1 by n this factor, if we multiply by 1 by n, then this also will be 0. That means the average speed or average velocity is equal to 0. Algebraic sum gives, suppose this is 3, this is 4, this is minus 3, this is minus 4, this is minus 5, there is another that is plus 5 or minus 5. So algebraic sum also will be equal to 0. Then if we take, for example, minus 1, plus 1, minus 2, plus 2, minus 2, plus 3, minus 2, minus 3. Similar expression. If we take a large number, then according to the rule of statistics, the summation will be 0. That is why summation of Vi, I represents ith particle or ith electron. Suppose this electron is designated by I. Okay. So Vi, I ranges from I is equal to 1 to n. I is equal to 1 to n. If we multiply by this factor by 1 by n, then this also will be 0. So this is the matter of discussion. But this condition is applicable only when this conductor is kept in normal condition. What is normal condition? That means suppose there is a specimen of iron that is taken for our experiment, a specimen of iron or specimen of copper. The shape of copper is like a copper thread or conductor of copper. Under normal condition, the average velocity of the free electron inside the metallic conductor would be equal to 0, and we can say the expression that is expressed in language, that is expressed in mathematical form. So you have to transfer the thought process or thinking process. The result of thinking process is a sentence in brief, and that sentence should be converted into a mathematical expression. And this is the mode of study of physics. Okay. Next, we shall take this conductor in another condition. Suppose this conductor, the same conductor, this is the conductor, and there are electrons. There are so many electrons. So this is the electron, one electron, another electron, and so many electrons are there. Now, electron is a charged particle, you know. The charge of the electron is equal to charge of electron, you know, is equal to E. This negative quantity, E is equal to minus 1.6 into 10 to the power minus 19 coulomb. This is the charge of the electron. So, precisely we can say, without mentioning the value, actual value, we can say the charge of the electron is equal to minus E. Okay. Now, if a potential difference is created with the help of a battery, suppose this is the battery and a potential difference is created. Suppose this is the battery, this is the mode of connection, this is the battery, and this is the mode of connection. Okay. So what is the function of this battery? It will establish a potential difference between 2 points A and B. The two terminals of the conductor is equal to A and B, and a potential difference, when a potential difference is established between two terminals of the conductor, it will create an electric field inside in this region. The electric field will be created in this region. The entire region, electric field E will be established. And any charged particle, the force experienced by an electron in a uniform electric field is equal to F. This is the expression for force. F is equal to minus E into E. Actually, if the charged particle is positive, then this will experience a force along the direction of the field. Then the direction of field and the direction of force experienced by the charged particle will be same. But in case of electron, the force experienced, the direction of the force experienced by the electron and the field will be different. So if we take the magnitude, for simplicity, if we take the magnitude of the force, then force is equal to F is equal to E into E. So this is the force experienced by the charge particle. It is not normal condition. So previously we have discussed about the normal condition. In normal condition, the average velocity of the free electron inside the conductor was 0, but under a specialized condition, the electron will experience a force. And as we know, the electron has a mass m. It will experience an acceleration due to the existence of force. Okay. So, the acceleration of the electron inside the conductor will be equal to the acceleration of the electron inside the conductor is equal to A. It's also vector quantity. A is equal to minus E divided by M, where E is equal to electronic charge and M is equal to electronic mass. So, the electron inside the conductor, when it is under influence of a field, it will experience a force. And as a result of the force, this electron will experience an acceleration along a fixed direction depending upon the direction of the field. That means depending upon the direction of the polarity of the battery. So, this electron, particular electron, suppose ith electron, we are concentrating on a special electron, that is ith electron. Among all the electrons, n number of electrons are there, and we are concentrating upon just on one electron. So, this is a ith electron will be in motion in a particular direction, and with an acceleration A is equal to, the magnitude of A is equal to, actually this is the direction A, vector A, and magnitude of A is equal to B E divided by M. Now, there are so many ions. The ions are fixed. This is an ion, positive ion, another ion, positive ion, another ion, positive ion. All the ions are fixed inside the conductor, and it will encounter collision. This electron, particular electron, will encounter collision when it will collide with an ion, then a collision will occur, and after successive collisions, so this is one collision, due to a collision with an ion, it will change its direction of motion, suppose along this direction, and there is another electron, and there is another ion here. This is positive ion, this is positive ion, this is positive ion, and this is the electron, okay. We are just changing the color. This is the electron. So electron is here, and then it will change its direction of motion. That means along this direction, it may move along this direction. And this is the new position of the electron and the ion. So this will move another direction. So this is the mode of movement of the electron inside a conductor when the electric field is established. between the two terminals or in this region. And the time interval between two successive collisions. Time interval between two successive collisions. Time interval. Time interval between two successive collisions is equal to tau. Tau is a Greek letter. Remind it. Is equal to tau. Suppose this is tau. And before one collision, suppose, so this is the initial, we are observing the ith electron, and this is the initial position of the electron, and this is time, a particular time. This is not relaxation time, particular time, and after time t, it will collide with another ion, positive ion, and after collision, it will move in another direction, then another collision here, and that it will move another direction along another direction, and this will continue, and the continuation of this process will give the electron a velocity along a particular direction depending upon the field. So the field determines the motion of the electron inside the conductor. Okay, and we know the acceleration of the electron A is equal to minus E by m. Okay, so if the velocity before collision is equal to 0, the velocity after collision is equal to v I is equal to 0 plus acceleration A into t. We know the formula v is equal to u plus at. In vector form, this is like this, and in scalar form, it is like this: v is equal to u plus at, where all the quantities have the usual meaning. Now, if we consider the velocity before collision is equal to 0, already we have proved this, then the velocity after a relaxation time t, velocity after relaxation time would be equal to v is equal to a means minus e by m tau. The velocity of the ith particle, ith electron, v is equal to minus e by m into tau, where tau is the relaxation time. So this is the expression for velocity. With this velocity, particular velocity, electron moves from one point to another. So due to movement of the electron inside the conductor, charge will move inside the conductor, and due to movement of charge, the current will be established. Now, you have to remember this expression, particularly this expression will be required for further discussion of our class. Particularly this expression will be required after a certain time. Now, we have to define a quantity that is called current density. Okay, so now we shall divert our attention to another topic, that is current density. And current density, what is current density? Suppose this is the conductor. This is the conductor, and this is the area of cross section A. Area of cross section A. And electric current has the direction along this. This is the current direction, I. Actually, the area is a plane area. This area and this direction of current are perpendicular to each other. This area and the direction of current are perpendicular to each other. Okay. Now, A is equal to area of cross section, I is equal to current, then current density J, it's a vector quantity. J is equal to I by A. J is equal to I by A. Current density is equal to J is equal to I. I is equal to current, A is equal to area. And provided the direction of electric current and the orientation of the area considered will be perpendicular to each other. Okay. So this is the definition of current density. You may go through the book. '96. Wait a bit. So this is the expression for current density. J is equal to, this is the current density is a vector quantity, and this is the magnitude of the current density. J is equal to I by A. I is equal to electric current, and A is equal to area of cross section. Okay. Now we shall re-enter into the previous topics. That is the origin of resistivity. Now once again we shall draw a conductor like this. This is the conductor. Better to write in another mode. So this is the conductor, metallic conductor. Now we shall define some quantities. N is equal to number of free electrons per meter cube. N. A is equal to area of cross section of the conductor. Vi is equal to velocity of the ith electron under consideration, and we have already discussed that the expression for Vi is equal to minus E by M into tau. Okay. This is also a vector quantity. E is equal to electronic charge. E or minus is equal to electronic charge. Now we consider a section inside the conductor of similar or same area of cross section. The area of cross section of this is equal to A, and the electrons are moving from point A to point B. This is the direction of motion of electron. V. This is the ith electron, and in general all the electrons move with a drift velocity that is equal to Vd. So this should be written as, in place of Vi, we can write it Vd, and this is a vector quantity, and Vd is independent of the time. Tau is equal to relaxation time, and it is applicable for all the electrons. Okay. Now consider a cylinder having length Vd, area of cross section A. If we consider a cylinder of length Vd, this stands for Vd, and area of cross section is equal to A, then the volume of this particular space is equal to volume is equal to A into Vd. It's a suffix. If number density of electrons, free electrons, is equal to n, then number of electrons inside this volume, number of electrons, free electrons actually, is equal to A Vd into n. This is the number of free electrons inside this particular volume. So the total amount of charge inside this volume, dq is equal to charge is equal to A into Vd into n into E, and this charge moves, this amount of charge moves along this direction in unit time. Actually, this is the length of Vd, and at the initiation of the second, 1 second, we are concentrating 1 second journey of the electrons. The journey of the electrons during 1 second. So when the second starts, the first electrons enters, and when the second ends, 1 second ends, the last electron enters, and in 1 second electrons move with a speed or velocity here, Vd, velocity Vd. So all the electrons within this space, that means all the electrons within this space will cross this cross section. So the number of electrons crossing this area in unit second or 1 second is equal to A into Vd into N. Okay. And the amount of charge that is crossing this area is equal to dq is equal to A Vd into Ne. Okay. So the electric current I is equal to delta q by delta t, dq by dt. You know this. So I is equal to, remember this expression, electric current is equal to I delta t or I dt is equal to dq, and that is equal to n e vd into n e vd into a. Electronic charge is equal to minus e, so this minus should be introduced here. dq is equal to a minus a vd ne, and so the current I is equal to delta q by delta t or dq by dt under this condition. So we can write dq is equal to I delta t, and I delta t is equal to minus a vd n e, and we have the expression for vd is equal to a, this is equal to minus e by m into tau, okay, into n into e into delta. That is equal to a e square n by m into delta t into tau into e. So I is equal to, this is dq, or delta q, delta or dq or I is equal to A n square tau by m into E, or J is equal to I by A is equal to n square tau by m into E. In vector notation, J is equal to n square tau by m. So we have the expression J is equal to J is equal to another page is required. J is equal to n square by m into tau. Here n is equal to constant number density, E is equal to constant electronic charge, tau has been taken to be constant. We assume tau is equal to constant, relaxation time is equal to constant, and m is also constant. M is mass, electronic mass, that is also constant. So all the constants, can be reduced in another form. Sigma. This n into E square into tau by m, all the constants are taken to be another constant sigma. Hence, J current density is equal to sigma into E. Actually, this is the original expression for Ohm's law. Now, from Ohm's law, if we draw an analogy between this law and Ohm's law, we know I is equal to V by R. Okay. So V is equal to electric field E is equal to V by L, when L is the length between two terminals. So I is equal to EL in place of V, EL. R is equal to rho L by A. That is equal to E A, EA, LL cancelled by rho, or I is equal to 1 by rho into E, I by A, or J is equal to 1 by rho into E. So we can say 1 by rho is equal to sigma. 1 by rho resistivity. Resistivity 1 by rho. From this equation, J is equal to sigma into E, and here J is equal to 1 by rho into E. From the known form of Ohm's law, I is equal to V by R, I is equal to EL, V is equal to EL by R is equal to rho L by A, and we have the relation E is equal to V by L. Okay. Now I is equal to, under this condition, I is equal to EA by rho, or J is equal to I by A, current density is equal to I 1 by rho into E. That means 1 by rho is equal to sigma. This is equal to sigma. This is known as resistivity. This is known as conductivity. So the resistivity rho is equal to from this relation, resistivity is equal to rho is equal to 1 by sigma conductivity, and we have already discussed sigma is equal to n squared tau by m. Sigma is equal to n squared tau by m. So this is equal to m by n squared tau. That implies rho, the resistivity, is dependent on mass of the electron, number density of the electron, electronic charge, and relaxation time. Mass of the electron is fixed. Charge of the electron is fixed. Number density, that means number of free electrons per unit volume, varies from conductor to conductor. That means in case of a conductor, number density, this number density particular, n is equal to number density, that means number of electrons per unit volume. That changes. And relaxation time, average, that also changes depending upon the situation. So resistivity comes from the electronic mass, electronic charge, electron density, and relaxation time. This is all about the relation between resistivity and electronic behavior.